Okay, I'm going to walk you through this example. What is the maximum amount of ammonia in grams that can be synthesized from 45.8 grams of NO and 12.4 grams of hydrogen? And they want to know the mass in grams of ammonia. Okay, so this is a limiting reagent problem because we have two reagents. We have NO and H2. One of those is likely to be in excess, and one of those will limit the amount of product we can get. But additionally, we're starting from the mass of NO and the mass of hydrogen. So we're going to have to convert to moles. Anytime you go from one chemical species to another in a chemical reaction, so in this case, we're going to go from NO to ammonia, you have to do it in mole-to-mole ratios. Same thing when we go from hydrogen to ammonia, mole-to-mole ratio. Because we interpret this equation as 2 moles of NO and 5 moles of hydrogen make 2 moles of ammonia and 2 moles of H2O. We cannot go directly from mass of reactant to mass of product. We have to use the stoichiometric ratios. And because this is a limiting reagent problem, we have to calculate the amount of product that both of them will create. The one that makes the least is the limiting reagent, and that amount is the quantity that can be produced. So let's get started. For NO, I have 45.8 grams of NO. And notice on this, I'm going to be writing the chemical species next to the unit because it's going to help me figure out which direction my stoichiometric ratios need to go. So 45.8 grams of NO. To get from mass of NO to moles, I'm going to use the molar mass. And I've already calculated that. That's 30.0 grams of NO per 1 mole of NO. So just a reminder, this is molar mass. So now I am in moles of NO. I want to get, however, I need to get from moles of NO to moles of ammonia. And in order to do that, I have to use a mole-to-mole or stoichiometric ratio. And those come from the coefficients in our balanced chemical equation. I want to get rid of NO and I want to keep ammonia. So I'm going to put 2 moles of NO in the denominator and 2 moles of ammonia in the numerator. So at this point, I have eliminated grams of NO, moles of NO, and I have moles of ammonia. But I need, in the end, I'm going to want grams. So I'm going to do, again, another molar mass conversion. So 1 mole of ammonia is 18.03 grams of ammonia. And now my moles of ammonia cancel and I have grams. And that number is 28.8 grams of ammonia. Now, because this is a limiting reagent problem, I have to do the whole process over for the other reagents, and in this case that is hydrogen, and I've been told that I have 12.4 grams of hydrogen, and I'm going to go from grams to moles. So it is 2.02 grams of hydrogen per 1 mole of hydrogen. Again, I'm keeping my chemical species together so that I know how to use my stoichiometric units so that they all cancel. Now I want to go from moles of hydrogen to moles of ammonia. I need a mole-to-mole or stoichiometric ratio, and for that I look at the coefficients. 5 moles of hydrogen are consumed in the production of 2 moles of NH3. And again, I want the mass of ammonia, so 1 mole of ammonia is 18.03 grams of ammonia. And that calculates to 44.3 grams of ammonia. Couple things to point out. My units that cancel: grams of hydrogen, moles of hydrogen, moles of hydrogen, moles of ammonia, and then I have the units I want. This is a molar mass conversion. This is mole to mole, and this is molar mass as well. It's the same process for both reagents. Okay, now, which one is my limiting reagent? Well, I look to see which one produces the least ammonia, and that is nitrogen monoxide, NO. That is my limiting reagent. Hydrogen gas is in excess, and the amount that I can expect to make, the maximum amount, is 28.8 grams.